One more minute. All right, watch closely. Jacob knows he understood every bit of it, so he doesn't have to pay any attention to this, right? Test next week. So I wanted to do a quiz like this because a lot of people are struggling with this. Got to pay close attention. It's not that difficult. You just got to be here and pay attention and understand it from the beginning. All right? If I want to write this as an if and then statement, remember you got a hypothesis and you got a conclusion. All right? What's our hypothesis in this statement? Measure of 167, right? What's the conclusion? It's an obtuse angle. So when I write this, I'm going to write it very, it's going to look like some first graders writing it. Because I don't like to write. If, that's goes first always. If what? Angle has measure 167 degrees. Then what? Then it's obtuse. That's your if and then statement. Is that statement true or false? True. Converse. What's the converse do? Switches it around, right? Just switches the order of it. Switches the hypothesis and the conclusion. What's the converse going to say then? All right, if angle is obtuse, then, and I'm going to shorten this up even more. What's the little m stand for? Measure is 167 degrees. As long as you can shorten things up as much as you possibly can, as long as I can still tell. All right? Had somebody yesterday who said they were shortening all their stuff up to this. Any idea what that is?
Oh.
That's what I said. Property of equality. And I said no, because I'm never going to understand that. So you can't shorten it up that far. All right? You got it within reason. Is that true or false? If you got an obtuse angle, whenever you're trying to decide whether these are true and false, it's where a lot of you are having trouble. You're trying to decide if they're true or false. You look at the first part. That's the part they're telling you. It's like you're given information. So we have what kind of angle? Obtuse. Then, do we know for sure that the measure is 167 degrees? No. Give me an example. 168. So that one's false. Inverse. All right. It negates. Negates just means you do the opposite for both parts. Go back to the original statement and negate it. So what's it going to say? If not, measure 167, something like that, then what? Then not obtuse. So look at what we're saying here. We got this angle and it's not 167 degrees. All right, give me an angle that's not 167 degrees. 163. Seth, the only angle you could have picked in the whole world that would be wrong, and you picked it. Come on now. Jacob, he's way off it. 166. So if it's 166 degrees, is it not obtuse? No, that's false, isn't it? Contrapositive. What's contrapositive do? Does both. So what's it going to, and remember, you could go right back to the inverse and do what to the inverse? Just switch it around. So what's it going to say? If not obtuse, then not 167 degrees. This is probably the hardest one to decide whether it's true or false. And we said if the original statement is true, about 99% of the time, what do you know about the contrapositive? It's true. So if you didn't know for sure and you made a guess on that one said true, you got a good chance of getting that one correct.
Is this paper the proofs?
Yeah, that's part of the notes that we're going to do here in a minute.
This is the proofs.
Huh?
No.
No, we're getting ready to do them here in a minute.
Oh, okay.
Give a counterexample. All real numbers are whole numbers. Explain to me what real numbers are. Any number that you know. So that's right. You don't know anything but real numbers right now. So every number you know is considered a real number. What's whole numbers? So give me is there a counterexample to show that all real numbers are not whole numbers? Go ahead.
Are not whole numbers? Pi. Well, 3.14.
Is that not a real number?
Yeah.
Or I'm sorry, it is a real number. Is it not a whole number?
Yeah.
Yeah, it's not a whole number because it's a fraction or a decimal. What other kind of numbers could you give? You could have given a negative number, right? As an example. This is what I want when you want counterexample. You want just a specific example. Don't explain to me. You want just a specific example. All right? The two-column proof. Somebody memorize that for me real quick. Got it?
Got it.
Tell me what it said.
3 parentheses 2x minus 2 parentheses equals 12.
This is the way a normal two-column proof problem is going to be written. It's going to say given, then it's going to say prove. All right, it's going to say given, then it's going to say prove. On these algebra ones, the proof statement's just going to be to figure out what x is. For the geometry stuff, it's going to be a little different. So if we're going to do this two-column proof, these are our statements, and I call them statements, and I didn't realize it, but this book doesn't call them statements. Anybody see what this book calls them? Equations. So if you see equations up here, that means the same thing as statements. So don't let that confuse you, because I'm going to say statements for the rest of my life, but it could say equations. Daniel, you getting all this way back here?
Yeah.
Focus. Focus. Don't. Focus. First one, we write in what they told us. How did we know that 3x or 3 times 2x minus 2 equal 2?
It was given.
It was given, and that's what you write.
It's 12 at the end.
12, sorry. Given. Then all you're going to do, from these, you're just going to work your way down. What's the next thing I do to start to solve this? Distributive property. Distributive property. Because I know Jacob understands all this. He doesn't focus. Lay it on my chair up there if you would. Thank you, sir. What do I get when I distribute? 6x minus 6 equals
12.
What did you do there? Distributive property. And that's what you write. And you can shorten it up a little bit. Distributive property. You're just given a reason. How did you go from number 1 to number 2? Use distributive property. Number 3. What do you do next?
Add 6 on both sides.
So you get 6x equals what?
18.
18. Now here, you got to be careful on this. Addition property of equality. It's got to have that of equality on the end, because addition property just means, see, Daniel, you learned something, didn't you? So it's a good thing that I made you pay attention. You got to have that of equality on the end, because if you just say addition property, this is addition property. 3 plus 2 gives you what? 5. Addition property of equality says you're doing something to both sides of the equal sign. Then what? So what do you end up with?
Division x equals 3.
X equals 3. What's our reason? Division property of equality. Now notice I will abbreviate just about everything that we do for the rest of the year in here. What's the two words I told you last time? Do not abbreviate. Subtraction and substitution. Subtraction and substitution. That help any? Can that help any? See, I'm not that bad a guy. That says quiz. On the homework, open up your books to page 97. Questions, problems you want to see worked off of page 97. That was the homework. 96. I bet you did do some of 97 because there were some problems on there. If you guys could correct yourself as easily as you correct me all the time, everybody would have 100% in here. '97, '96. I don't want to say it wrong again, Co. They'll be all over me. Questions, problems you want to see worked off of 96?
15 and 16.
I'll sit like this.
Didn't even do 15.
I just can't sit like this.
47.
No, are you gonna check this?
Maybe.
No.
Yeah.
Questions?
Nine.
Problem 9. Problem 9, the given information this time. Read the given information to me, please, Lily.
5. Parentheses.
Oh, we just did that, never mind.
That's all right, we'll do no.
3x minus 20 equals negative 10.
So, again, they're calling these equations. I don't want to call them equations. I'm going to call them statements probably most of the time. This is our reasons. You got to make sure. I walked around as I was walking around. You got to number these. They got to match up, and you got to have a number on your equation, the number on your reason every single time. All right. What's our first equation going to be here? That right there. And our reason is going to be given. Now, when you're doing the geometry stuff, a lot of the two-column proofs will have more than one given statement. Right? They might have 2, 3, 4 given statements. So they'll give you more information. They'll say angle A is congruent to angle B. Angle Q is congruent to angle R. And they'll give you a whole bunch of information, and then you build off of that. Usually these algebra ones, not that way. What's this tell us? What do we do? Or what do we have?
Minus 100. Negative 10.
What's our reason? Distributive property. And you could put of equality on that if you want. Distributive property doesn't really have to have the of equality because you're not doing it to both sides. What's number 3 say? Or going to say?
15x.
15x equals 90. What do we do there?
Addition.
So if I just put add, is that going to work? If I just put add property, is that going to work?
No.
Of equality. Number 4. What do you do next? What do we get?
X equals 6.
Property of equality.
Division property of
What's number 5 going to say? That's it. How do you know that's it? That's what you're trying to prove. Now you'll know you're done. You'll know you're done when you get to whatever it says prove. All right? The geometry ones will always have something right here. They'll say prove, then whatever. The algebra ones don't do that because they just figure that you know that you're going till you solve for whatever x is.
15, 16.
Which one?
15 and 16.
Pick one of them for me.
5x plus y equals
Which number is this?
15.
So say it again.
5x plus y equals 18.
Oops. 5x plus y equals what?
18.
18. What'd they ask us to do?
Sum the equation just to make steps.
Find one.
To find y. So we want to get y all by itself, right? I'm going to put this. Again, Michael knows I'm pretty lazy, Michael, so what's S stand for? Statements. What's R stand for? Reasons. What's our first statement going to be?
5x plus y equals 18.
How do we know that?
Given.
It's real difficult. They wanted to solve for y. What do you got to do to get y by itself? Subtract 5x, so you end up with y equals what? Negative 5x plus 18. What did we use there? Subtraction. You could go out that far, then I'll know it's subtraction. Subtraction property of quality. What do we got to do next? That's it, isn't it?
Yeah.
Because it just wanted us to get y by itself. We're done.
That's easy.
2 steps. Other.
I have a question on this right here.
We're getting ready to do that together here in a minute.
Alright, first call.
Other questions? Probably accept that if you number these over here. The whole purpose of the chart is you're not supposed to show your work in the problem. So that whoever looks at this next tablet, they look at it and they go, how in the world did she go from here to there? And then you look over here, subtraction property. Oh, she subtracted 5x on both sides. So we really don't want to show our work in the middle there when we're doing this, these 2 column proofs. Sorta.
What if we do show our work?
Then do this. If you show your work, so if you did this on this problem, so if it helps you, then when you're done, go back and erase it.
Could you like knock out that off in the quiz if we didn't know that? Next time I'll do that.
Maybe, we'll see.
Oh, where's the moment that's
47. Watch on 47. Watch on problem 47 because these are the ones that we're going to do today and they're a little bit harder. And this is the kind that they would put on the end of the year test. On the end of the year test, they're going to give you a box that looks like this probably. And then they'll have like answers up here. And guess what you got to do with those answers? Drag them and put them in the correct places. All right? So sort of the same idea, just give me a second so I can get this written down. But this is the kind of problems we're going to do today. Stuff from last time was algebra. Now we're dealing with geometry stuff. You're not doing stupid stuff while my back's turned, all right? You were about to. And again, they didn't number them. I want you to number them every single time. Number your equations and statements and reasons every time. Not sure why they don't do it. Do me a favor and read me off the rest of this, because something else that I don't like about what geometry books do. They take all the given information and they stick it all in one statement. I'd rather you did not ever do that. All right? Separate it. If this is on a test, we have a test next week over chapter 2, and if I put this problem on the test, right now with that, how many points do you have?
1.
1. If you do this, what's the next one say? In that first box.
Measurement of angle 2 equals measurement of angle 3.
Is that right?
I don't know, that's the only other angle left.
Hazel's lying to me.
Hold on.
Hey, I don't
The
know,
next
I'm
box-
trying.
the Next thing in that box.
Look, next thing in that first box on the problem.
Angle EHF equals 90 degrees.
EHF.
Oh, EHF equals 90 degrees. And measurement of angle.
Slow down, slow down. How did we know that?
It was given.
Now, all I'm doing
Why did
here,
they put them all together?
they stick them all together,
But you
and,
don't
and to
listen
me
to
that's
them.
dumb. No, because as soon as you stick them all together and you look at the first one, what happens with the other two? You lose it. You forget all about it. So if you separate them, it's going to make it easier on you. Not to mention, if I put this on the test next week, what's the next one say?
2 and 3.
There's still another part in there.
Yeah.
equals and angle
You're too far down. We're still in that first box. How did we know that?
Give
It was given. How many points am I going to give you for what you have right now?
3.
1,
6.
6 points.
oh,
If you
oh.
stuck all this up here in 1,
That's 3.
if you stuck that all up there in 1, how many points you going to get? 2 points. Which is better?
6.
6.
So separate it. All right? That makes sense? Now, let's look over here. Once we have all this given information, we know that angle 1 and angle 4 are congruent. We marked them in the picture, right? And they tell us that this angle, EHF, is a right angle. The box shows us that. And we also know that GHF is a right angle. All right? What can you tell me about, let's just brainstorm here. What can you tell me about these two angles? They're congruent to each other because they have the same measure, right? What can you tell me about angle 1 and angle 2? They're complementary, all right? They're also, we know that angle 1 plus angle 2 has to add up to be what angle?
90 degrees.
EHF. Use an angle addition postulate. Remember that, where we took two angles? Said this angle plus this angle has to equal the whole thing, right? So angle 3 and angle 4 have to add up to be which angle? GHF. Probably somewhere through here we're going to use that. What's the next box say after they put all that given in that first box? What's the second box say?
Measurement of angle EHF equals measurement angle GH.
Yeah, well, we already know that.
We already know because we just thought it through, didn't we? Now, what you could write over here for your reason, how did we know that these two were the same? Because they have the same measure. We could put that. You could also put this. If we know that this one equals 90 and this one equals 90, could we take out this 90 right here and stick that in its place?
Yeah.
What did I just do there? Substitution. Could we use substitution?
Yeah.
Yeah, so whichever one happens to be easier to write, probably the one you want to use. I don't know, what did they use? Did they already have that one filled in? No, so substitution property is what we're going to put. If you put in there same measurements, that would be fine also. What's the next equation say? Did they give it to us after this one? Don't go by my numbers.
EHF equals measure of angle 1 plus measure of angle 2.
How did they know that angle 1 and angle 2 together give you EHF? What did they use there? We just said it a second ago. Angle addition postulate. So 5 right here would be angle addition postulate. This angle plus this angle has to equal the whole thing.
Yeah.
Number 6. Did they tell us something else after that?
Yeah.
Or did they leave it blank?
Angle 2 and angle 3 equals angle 3, yeah.
Angle 2 equals angle 3?
Yeah.
Wait, no,
That's-
there's
more
more
to
to
it.
There's another one.
Oh, there's another one in that same box? What did it say?
Measurement of angle GHF equals measure of angle 3 plus measure of angle 4.
These I don't mind if you put them together because they sort of go together and it's still angle addition postulate. So that makes more sense to put those together than it does all the given. Because then we don't have to write angle addition postulate twice. Now look at what we have here. Measure of angle EHF equals angle 1 plus angle 2. Measure of angle GHF equals that. If we look back up through here, what's the next one say that they had here?
Measure of angle 1 plus
They give us the reason this time?
No. No. Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4.
Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. So look at what they did. What did you know about these two angles? What do we say right here? These two are what? They're the same. If these two are the same, what's that tell us about these two things over here? They gotta be the same. Did I write that wrong? That should be 3 plus 4, shouldn't it? I wrote it wrong. What's our reason there? What did we use? Substitution would work. If you wrote transitive property in there, I'd probably accept that also. Substitution, transitive property. Did they give us the next statement?
No. They gave us the reason.
It's blank. They gave us the reason again.
Yeah.
What reason?
Substitution.
They said substitution again. Substitution property. Now what we're gonna do here, and this step seems sort of dumb to me, but they do it sometimes. They like, and this will make Davlin happy because what they do is they sort of show their work in this step. They got angle 1 plus angle 2 equals angle 3 plus angle 4. Well, what do we know about angle 1 and angle 4? They're the same. So if I have angle 4 over here, I could take it out and stick what in its place? So I'm going to do this. Measure of angle 1 plus measure of angle 2 equals the measure of angle 3 plus the measure of angle 1. All I did was took this out, substituted in its place. If I know that they're congruent, I wouldn't do that. I'd just say, hey, 1 and 4 are congruent, so they're the same thing. We could just get rid of them. But they do it that way. So they just took out 4, stuck in 1. I'm going to move over here and put 8 because I'm running out of space. Once you know you got an angle 1 over here and an angle 1 over here, what could you do with them? If you got an x on this side of the equation, you got an x on this side of the equation, what could you do with them? Just get rid of them, right? Cancel them out. So if you got an angle 1 here, you can cancel it out. Angle 1 there, cancel it out. What are you left with? Measure of angle 2 equals the measure of angle 3. Hey, what were we trying to prove? Measure of angle 2 was equal to the measure of angle 3. What's our reason going to be? What did I do when I canceled those out? What property? Subtraction, property of equality. Make any sense? Now, Jacob up here, he's gonna have trouble with these, and I know people's gonna have trouble with these, especially when you're filling in stuff. Could you make a guess at least
Yeah.
and put stuff in there? So if you got blanks, don't just leave it blank. Make a guess, write something in there. You look at this and you go, what did they do to go from here to here? Maybe they use substitution. It looks like maybe substitution. So you write down substitution. Maybe you get lucky. All right, the other papers. On the other papers. At the end of class, I'm going to try to go over this if we have time. If we don't have time, just real quickly, this tells you what's supposed to be in your binders. You got how many sections in your binder? 3. This one goes along with your notes today. Start copying this down. Look, Maisel.
I see.
Do you have anything under taxes?
Not yet. We're going to try. That's one of the things we're going to try to talk about. On a clean sheet of paper. And put the two together in your binder. No, you don't do that. You didn't get those two the first time? Come on, Co, you're slipping on me today. Come on, Co. He was spelling his name. He wrote C-O. And I said, "Do you need me to help you, man?" Write this quickly. Again, clean sheet of paper. Clean sheet of paper. Start these notes on that clean sheet of paper. Then put the other handout in with that clean sheet of paper in your binder. Does that make sense so far to everybody? Mr. Woodall, that makes sense? You see why my hair is turning gray and falling out? Huh? You don't see why? When I say the same thing 75 times. Trying to think of math teacher that you can count to so that figure that out. Well, we're going to cover using properties of congruency. Last time we covered properties of what? We said it about 10 times already today. Equality. Properties of equality. Now we're going to talk about properties of congruency. So instead of dealing with things like x equals 5 and stuff like that, we're going to deal with segments and angles. All right? Be able to write 2-column proofs just like that last one that we just got done doing. Write those two definitions down. A proof is a logical argument that uses deductive reasoning. What's the difference between deductive reasoning and inductive reasoning? What's inductive reasoning use?
It's in the thing, right? In the
Inductive reasoning uses what? Starts with a P. Patterns. Thank you. Patterns. All right? Inductive reasoning uses patterns. Deductive reasoning uses what? Facts, rules, laws, whatever. All right? So inductive reasoning, patterns, deductive reasoning, facts. I know this because of the subtraction property of equality. I know this is true because of substitution property, so on and so on. 2-column proof has numbered statements and corresponding reasons. Make sure you number your statements and reasons. And you might want to write in here instead of statements, because I messed up and didn't read the book very carefully. I've never seen a book that put that before. But this book says equations instead of statements. Does it really matter?
No.
No. Now, before we go on to the next 3 or 4 slides, Jacob's going to be my muscle here. Jacob, if you hear anybody complain, we already wrote this down. you know what to do, right?
That's convenient.
No, it's not. So don't complain, you're gonna write some of the same stuff over again, but it's a little different.
What is the?
Caleb, is that gonna kill you? No.
Well,
If it does, Caleb, then Michael will help me drag you out in the hallway, cause
I could probably do it myself.
we sure don't want that headache on a Friday to do all that paperwork, do we?
Not real.
Give it to somebody else. Draw this, a 2-column proof looks like that. You have statements, you have reasons. You gotta make sure you number each one so that they match up. Sometimes there'll be 2. Sometimes there'll only be 2 statements and reasons. Sometimes there might be 10. Alright, we just got done doing a problem. The one had 2, right? 2 steps.
Yeah.
The next one had like 8. Then another one had 6. Then another one had 4. I think the one on the quiz had 4, right? So all different kinds. There's no set amount. You make a statement and you give a reason for that statement. Now when I said you separate things and you get more points, I can see the wheels turning in Nathan's head back here where he's thinking, you know what, I'm just going to put in statements like 5 plus 3 equals 8. And the reason for that is addition. And I'm just going to put in a whole bunch so he gives me a bunch of extra points. That's not how it works. You put in extra stuff, I take off points if it doesn't go along with the 2-column proof. Everybody understand that? That makes sense?
Yeah.
I had somebody last year who tried, I never even thought about it before, and then they were smart enough. They weren't smart enough to actually do the 2-column proof, but they could add in a whole bunch of stuff thinking I was going to give them points for just because they had 15 steps on it. Your reasons, all the time, your reasons are always going to be theorems, postulates, definitions, properties, some kind of rule, except for one of them. Which one's not going to be one of those things? The first one, it's going to be given. The second one might be given also. The third one might be given. But all the rest of them are going to be something like that. All right, some kind of postulate, property, some kind of rule. Angle addition postulate, segment addition postulate. Vertical angles are congruent, so on, so on, so on. Some kind of rule. A theorem, what's the difference between a theorem and a postulate?
Theorem can be proven, statement had to be assumed.
All right. Postulate is something that we assume to be true. Theorem is something that you have to prove is true. So theorem is a statement that must be proven true. Seth's going to come up with his own theorem. He's got to prove it, right?
Yeah.
He wants to come up with a postulate. We're just going to assume because his name's Seth that it's true. Isn't that right, Jacob? You just believe everything Seth says, right? Talked about those earlier this year, right?
Yeah.
All right, this. We wrote this down last time, except, this is the part I don't want any complaining about. You look at this right here, how is this different than what we wrote down last time? Properties of segment congruency. Last time we wrote down properties instead of congruency here, what was it? Equality. So this is a little different, so write this down. Before you write it down, a couple of things. Theorem 2.1. I never ever want to hear you say, oh yeah, that's Theorem 2.1, because I won't have a clue what you're talking about. All right, that's the way the book's got it numbered. What we care about is properties of segment congruency. What's the reflexive property say again?
Equals itself.
Anything equals itself. Very good. Anything equals itself. You gotta remember that. So Colton's gonna remember anytime I say reflexive property, he's just gonna say what 3 words to me? Anything equals itself. Anything equals itself.
You should have had
Yeah, because when I made this up, Jacob, I knew all your heights. Reflexive property. Reflexive property again says anything equals itself. What's symmetric property do?
Everything is like flipped.
You just flip the 2 sides of the equal sign. Nothing harder than that. Transitive property. Transitive property for segments. One segment's congruent to another segment. That segment's congruent to something else. Then what do you know about the first one and the last one? They're congruent to each other.
Change it.
Desiree, you told me you were going to look up here the whole time. Lied to me. Yeah, because you were just looking back. Now you're going to make you sit up in your chair, right? I didn't know I was trying to be nice. It's not an argument we want to have. Because
Okay.
I'm going to win.
Let's learn this.
Somebody was still right. Everybody get it now? Yes, no, maybe? Now, Miles, I'm going to be nice to you because this does say the same thing, all right? See, I'm not that bad a guy. You haven't written that much today, have you? No. All right, thank you. Huh?
I understand you were.
I know, but you sort of gave me the attitude like, oh my God, you make me do this. So, write this down. And then what I want you to do is this. Draw an arrow pointing back at what you just wrote down for segments. And I want you to write this. All works for angles also. Do what? Yeah, there's a K in there, Daniel. So it works for angles also. So when we're doing the reflexive property, give me an example of the reflexive property using angles. Don't use mine.
Like angle 90 degrees, an angle of 90 degrees.
Too much.
Angle BC equal to angle.
The segment. That's the segment.
Angle BCE is equal to
Oh,
angle
yeah,
BCE.
yeah, yeah.
You guys make it too hard. Why couldn't somebody just done something like angle 8 is congruent to what?
Angle eight.
Angle 8. Make it easy. That's too much. Well, they were using 3 letters and wanted to make it harder than it had to be. Symmetric property just says you can flip it around. It still gives you the same thing. Transitive property. This angle equals the second angle equals some third angle. Then I know the first and the third angles have to be equal to each other. All right. Get out the other paper. We're going to do those together. Open up the door so you can see this a little better. Turn off light. Do what?
I didn't grab the
Yeah. That's all I said it like 162,000 times.
Grab it any. It's in like. You have to read the board. Like, he even says read the board on.
Quickly, because we only got like 15 minutes and we're going to get through a whole bunch of this. Miss Laird up here, she doesn't need to see how to do any of these 2-column proofs because they're all easy to her, right? Probably not easy to any of you, so make sure you watch and follow along. The given information this time, they say segment AC equals segment AB plus segment AB. That's not a typo. They're saying if segment AB is 6, then what do you know about segment AC? It's 2 times that. It's double that. All right? It's 12. So let's look at this. AC equals AB plus AB. How did we know that? It was given to us. Then the next one. They say this. Segment AB plus segment BC equals segment AC. What is that?
I got this substitution.
Say it louder, Miss Davis. Segment addition postulate. We've been doing that since like second day of school, right? Segment addition postulate. This segment plus this segment should equal the whole thing. I should probably write that out. Colton W, if I don't write everything out, do you understand what I'm doing? You wouldn't lie to me, would you? You gotta tell me if I'm confusing any of you. You don't, Mallory, you don't understand it?
No, I said I'd yell at you if I didn't understand.
Okay. Oh, and that's what I'd like. Now, if you yell at me and you're rude, then
No,
I'll probably be rude back.
back.
Next one. Look at what we have here. Look at number 1, number 2. You see anything in 1 and 2 they have in common? They both have AC in it, don't they? Well, if AC equals this and AC equals this, what's that tell us about those two things? They got to be equal to each other, and that's what they did down here in number 3. What property does that show? It could be transitive. I'm not going to use transitive. Substitution property. Transitive property is a form of substitution. So anywhere that your answer is transitive property, your answer could also be substitution. But it doesn't work the other way around. Anywhere your answer is substitution, it doesn't necessarily have to be transitive property. It's a form of it. So you'll probably never ever see me write transitive property because I usually just write substitution because I know that fits all of it. Once we have this, you notice anything in statement 3 here? You got an AB on each side, don't you? So I got an AB right here, I got an AB right there. What could we do with those? We could get rid of them. Alright, we could get rid of those two. What are we left with? AB equals BC. If we get rid of them, what's that called in math? So we do subtraction property of equality. And you could put subtraction property of congruency in there. I wouldn't mind that. Usually if we're using congruency, we'll have the symbols and stuff in there, and we won't be doing addition, subtraction. So, where do we go to next? Next problem, right? Because that one's done. Makes sense. Next one. Look at the given information. Measure of angle 1 equals measure of angle 3. What's that tell me over here then? So, let's mark them the same. I think on your paper they're already marked. I hate it when they mark it for you because you need to know how to mark them and stuff. But they've already marked them. Now, as I'm looking at this picture, as soon as I see a picture like this, forget everything that they've got written down there. I look at it and I say, hey, look at angle 1 and angle 2. If I put those two angles together, what angle do I get?
Angle D,
CBD. What did I use there? Angle addition postulate. Look at angle 2 and angle 3. If I put those two together, what angle do I get? ABE, EBA, one of those two names, right? That might be something that we're going to use down through here somewhere because of just looking at the picture. Let's go through and do their blanks that they got here. What's number 1 going to be? Measure of angle 1 equals measure of angle 3. How do we know that? Yeah. Oh, then look at what they did do next. Angle 2 and angle 3 together added up to be what angle? EBA. You guys just told me that a second ago, right? How do we know that? Angle addition postulate. What'd they do to go from statement 2 to statement 3? Substitution. They took out angle 3 here and put what in its place? Angle 1, because we knew angle 3 and angle 1 were the same. So they used substitution. Now, does anybody know what commutative property of addition is? We didn't talk about this one. Commutative property, commute, what's commute mean? Move. Alright, you move. And all it's saying is you move them. So commutative property of addition says 4 plus 2 is the same as saying what? 2 plus 4. So all it's going to do is take these two and flip them around. So measure of angle 1 plus measure of angle 2. If you forget that step as you're doing one of these 2-column proofs where it's not fill in the blank like this, I'm probably not going to throw a big fit because I would never ever do that. That's one of those little technical things that who really cares as long as you get to where you need to go. Now they did it that way. We look down here. Says that they used angle addition postulate again. We'll look back over there. Angle 1 and angle 2. You told me they should combine up to give you what angle?
CBD.
CBD. Cole, you getting all this or you mess around on something else? Cole, you getting all this or you mess around on something else? He's always on something else. Now, look at what we have here. Angle. Measure of angle EBA equals 1 plus 2. Measure of angle 1 plus 2 equals CBD. What do you notice about this and this? It's the same, isn't it? So what's that tell us about these two? So what can I write right down here?
Measurement angle EBA is congruent to measurement, or equals measurement angle CBD.
What did we just use there? Transitive property of equality. Again, I would probably put substitution property in there instead of transitive, but since they already have it written for us.
Well, they always tell you like to give.
Yeah. This is the way these 2-column proofs are always going to look. They're going to tell you what you're given, and then they're going to tell you what you're trying to prove. Sometimes they'll have blanks like this. I hate it when they put the blanks in there because in real life, is somebody going to fill in part of the blanks for you? No, you're going to have to think things through on your own. But they're trying to lead you into it easily. All right, look at this next one. The given information this time says angle AEB is complementary to angle BEC. So AEB, that's this angle, is complementary to angle BEC. What's that tell us about those two angles? Together they add up to 90. So what do I know about angle AEC here then? 90 degrees. So I could put that in there. And this is just thinking things through. We know that that's 90 degrees in. Just thinking, using your head.
On number 2, would you put measurement angle AEB plus measurement,
Wait, never mind.
We'll figure it out here in a second. What are we trying to get to?
90 degrees.
What angle is 90 degrees?
AED.
This angle over here, right? Do we know that that's 90?
Yeah.
Sort of explain to me. You know that this part over here is 90.
because
It's the same.
DEC is a straight angle.
So
It's
somewhere in
180.
there, we're going to have to say DEC equals how much?
180.
180. Then we can say that this one over here has to be 90 by subtracting off that 90, right?
Yeah.
So that's probably, we can probably think this through.
Yeah, okay.
Angle AEB is complementary angle BEC. That was given to us. So let's put that in there. What do you think we're going to put on number 2? Let's look at what else they have. Maybe that'll help us. Angle AEC equals the measure of angle AEB plus the measure of angle BEC. What did they use there? Close. Angle addition postulate. My pen would write. Any ideas on that second one?
Nope, still not a clue.
What did complementary tell us?
Angle BEC is equal to angle AEB.
So substitution.
About measure of angle. What do we have right here? What two angles?
AEB and would it be a measurement of angle AEB plus measurement of angle BEC equals 90? Okay, that's what I started saying earlier.
Should've finished.
Thank you.
Now look at what we have. We knew that these two had to add up together to give us 90
Would
because
that
they told
still
us
be
they
an
were
angle
complementary.
addition postulate though?
Now, what did we use there? What told you that these two added up to be 90? What word? Complementary. So just write something like complementary angles. What? Add up to 90 degrees. The book will probably just say something like definition of complementary angles. I'd rather you didn't do that.
So can I feel like complementary angles equal 90 degrees?
How did we know then that this was 90? What'd they do here? Substitution property. What don't you get? All of it? So let's go back. What'd they tell us up here? What's the key word in this first one? Complementary. What's complementary tell you about the angles? They add up to 90. Use what you learned up here to get what you get in the next one. Now, 2 to 3 really don't have anything to do with each other. But then we use 2 and 3 together because we now know this equals 90. That's the same thing as we got right here. So we could say that that angle has to equal 90. And that's where we use
On number 5,
substitution.
would you
Lesson over.
put supplementary angles equal 180?
Yep, you could write that. Or you could write a straight angle is 180. That's your assignment, page 103. Try, don't just give up because you don't like these 2 column proofs. You do that and that's not going to help anybody. Except for Jacob, because that'll make him look smarter than all of you still. Have a good weekend. Good luck tonight, fellas.
Yeah, they're gonna need them.
I don't know, Jacob. David said might understand this stuff just as well as you. Michael, is this your cup?
I have sunglasses. Oh, yeah. Yeah. It just made it brighter. It was like orange.
How about the notebook thing? Is that yours?
It looked through it.
Notebook
I
paper?
don't think so. If you just look at the
Probably Co's over here.
Probably.
Is that your notebook paper?
Are you not grading the homework that you're supposed to do?
Nah, I just wanted to go